Have you ever wondered why, as our instruments pierce deeper into the infinite dark of the night sky, the universe feels less like a predictable machine and more like an unfathomable mystery? For thousands of years, human beings have looked up at the quiet, glittering tapestry above us and sought an ultimate truth, a grand architect, or a definitive theory of everything. Many cultures have called this ultimate reality God, while others call it the cosmos. But the underlying human desire remains exactly the same, a profound need to make sense of the vastness that surrounds us. We'd naturally expect that as we gather more data, as we build larger lenses and send more sensitive probes into the silence of the void, the pieces of the cosmic puzzle will neatly snap together into a perfectly logical picture. We anticipate a universe that obeys our earthly common sense. But a gentle paradox awaits anyone who truly studies the heavens. The more we study the ultimate nature of reality, the less sense it makes to our everyday intuition. The more we map the ancient and infinite stretches of space, the more our ordinary perception of reality is challenged by phenomena that defy logic. If you are a curious explorer of the cosmos seeking peace through understanding, you have come to the right place. Hello, my name is Theodore, the researcher, and I will be your companion on this quiet journey through the greatest mysteries of existence. I have noticed that 71% of the people who watch our explorations have not yet subscribed to the channel. If you find comfort and wonder in these cosmic journeys, please take a gentle moment to subscribe, as it helps us immensely and ensures we can continue unraveling the universe together. Now, let us leave the noise of the world behind and step into the boundless dark. Consider for a moment the gentle stillness you feel right now as you sit or lie down, breathing softly in the quiet of your room. Your senses tell you that you're perfectly at rest, firmly anchored to a solid, unmoving world. But cosmic reality tells a completely different, almost unimaginable story. You are currently hurtling through the vacuum of space aboard a rocky planet that is orbiting a star, our sun, which itself is racing around the center of our home galaxy, the Milky Way, at a staggering speed of about 500,000 miles per hour. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. Astronomers sometimes call this period a cosmic year or a galactic year. To put that immense time scale into perspective, the last time our sun was in roughly this position in the galaxy, the most complex life on Earth consisted of simple marine organisms. And in the entire time that dinosaurs roamed the Earth, our solar system did not even complete one full orbit. This is the first profound contradiction between our daily experience and the ancient truth of the cosmos. We feel stillness, but we are participating in a grand, perpetual motion, and the space in which we move is almost unimaginably empty. Our nearest stellar neighbor, a small red dwarf called Proxima Centauri, sits about 4.24 light-years away. That distance is so profoundly great that if you were to shrink our sun down to the size of a single grain of sand, Proxima Centauri would be another tiny grain of sand sitting about 4 miles away, with nothing but an essential void in between, containing only the faintest whiff of gas and dust and the occasional particle of cosmic radiation. We are completely surrounded by emptiness, yet this emptiness holds the staggering mass of somewhere between 200 billion and 400 billion stars within the Milky Way alone. How can the universe be so incredibly empty and yet so unimaginably full? It is a paradox that humbles the mind and invites a deep sense of respectful wonder. For most of human history, we assumed that our local neighborhood was everything there was. Ancient people looked up at the night sky from dark locations and saw a hazy band of light stretching overhead, assuming it was the entirety of creation. They thought it looked like spilled milk across the heavens, which is precisely where the name Milky Way comes from. The ancient Greeks told beautiful stories of milk spilled from the goddess Hera, while the Romans called it the Via Lactea, the Milky Road. In India, it was seen as the quiet path souls take on their journey to the afterlife, and Aboriginal Australians saw it as a gentle river in the sky. People throughout history have looked up at that exact same band of light and wondered what ultimate mysteries it might hold. We thought our galaxy was the entire universe. We thought the grand design, the mind of God, was contained within that single glowing tapestry. But the universe is infinitely more complex than our early stories could capture. When the first telescopes were turned toward the Milky Way in the 17th century, observers began to realize that the milky glow actually resolved into countless individual stars, far too faint and too numerous to see with the naked eye alone. This was the very first hint that our galaxy was far larger and contained far more stars than anyone had previously imagined. Yet, the true shock to our existential understanding was still waiting in the dark. It was not until the 1920s that an astronomer named Edwin Hubble proved that those fuzzy smudges people had been observing through their telescopes were actually entire galaxies themselves, each one containing billions of their own stars, and each one impossibly far away from us. Hubble made this reality-shattering discovery at the Mount Wilson Observatory in California using what was then the largest telescope in the world, a reflector with a mirror measuring 100 inches across. He was observing a class of stars called Cepheid variables in what was then called the Andromeda Nebula. These unique stars pulse in brightness with a regular period, and by measuring their apparent brightness and pulsation rate, Hubble could calculate exactly how far away they were. The result was nothing short of shocking. The Andromeda Nebula was not a simple cloud of gas within our own galaxy, as many astronomers had confidently assumed. It was an entirely separate galaxy, an island universe of stars in its own right, sitting far beyond the outer edges of the Milky Way. We now know that the Andromeda Galaxy is actually about 2 million light-years away. The profound implication of this discovery fundamentally changed everything we thought we knew about our place in the cosmos. Our galaxy was not the whole cosmos. It was merely one single galaxy among many. Today, astronomers estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion is a 2 followed by 12 zeros. Each of those individual galaxies contains billions or even trillions of stars, making the numbers become so impossibly large that they simply stop meaning anything to our limited human brains. This is the very essence of the cosmic paradox we face today. The more we study the ultimate architecture of reality, the more the traditional concepts of a neat, comprehensible universe begin to dissolve. If the universe is the physical manifestation of a divine thought, then that thought is so vast, so incredibly intricate, and so terrifyingly beautiful that it shatters our terrestrial logic. We are forced to transition from being passive observers of a small, comfortable world into curious explorers of an infinite mystery. We must embrace the absolute humility that comes with realizing our true scale. We are tiny, brief flickers of consciousness in a universe that is ancient beyond our comprehension. Yet, In this immense ocean of silence and dark energy, the fact that we can observe, measure, and contemplate these 2 trillion galaxies is a miracle of existence. It shows that we are not separate from the mysteries we observe. We are the universe observing itself from within. We are made of the exact same star stuff, forged in the ancient nuclear furnaces of primordial suns. As we stand on the threshold of even deeper revelations, we must prepare our minds to let go of everything we thought made sense. The gentle journey into the unknown has only just begun, and the deeper we travel into the shadows of the cosmos, the more we will realize that true peace comes not from having all the final answers, but from learning to deeply love the infinite questions. We will continue to navigate these cosmic waters together, exploring not just what we know, but the vast, beautiful expanse of what remains hidden in the dark. The universe is calling to us in a voice made of starlight and gravity, inviting us to look closer, to think deeper, and to drift peacefully into its profound embrace. As we drift further into the ancient silence of the cosmos, we encounter another profound paradox that challenges our deeply held assumptions about order and design. When we imagine the universe, our minds naturally gravitate toward images of perfect harmony and elegant mathematical precision. We picture galaxies like our own Milky Way, with its beautiful, curving arms made of stars, gas, and dust, swirling gracefully around a central bulge in a magnificent cosmic pinwheel. These spiral galaxies, which are the most common type in the nearby universe, seem like the ultimate expression of a divine, orderly plan. They are vibrant sites of active star formation, where delicate stellar nurseries are cradled within gas-rich spiral arms, maintained by a delicate balance between the rotational motion of the galactic disk and the inward gravitational pull of all the matter within it. It is a picture of serene, clockwork perfection. If you are finding comfort in this quiet journey of discovery, please allow me to introduce myself. I am Theodore, the researcher, your gentle guide through the mysteries of the cosmos. I have noticed that 71% of the people who watch our videos have not yet subscribed. Please consider taking a gentle moment to subscribe to the channel, as it helps us immensely and ensures we can continue exploring these beautiful cosmic phenomena together. Now, returning to the vastness of space, the brilliant astrophysicist Neil deGrasse Tyson once gently reminded us that the universe is under no obligation to make sense to you. When we peer deeper into the infinite dark beyond our local neighborhood, we discover that this beautiful symmetry is merely one fleeting phase in a much grander, far more chaotic cosmic dance. The universe does not solely build through peaceful accumulation. It also builds through a staggering violence that unfolds over billions of years. Galaxies are not solitary islands floating peacefully in an empty void. They are organized into much larger structures, held together by the inescapable bonds of mutual gravitational attraction. There are galaxy groups containing a handful to a few dozen galaxies, much like our own local group, which houses about 80 known galaxies, including Andromeda and several dozen smaller dwarf galaxies. Beyond these groups lie galaxy clusters containing hundreds to thousands of galaxies, and the grandest structures of all, superclusters, which are vast assemblages of galaxy clusters stretching across hundreds of millions of light years. Within these dense gravitational environments, the illusion of peaceful isolation shatters completely. Here, in the deepest depths of the universe, galaxies do not simply coexist. They collide, tear each other apart, and consume one another in a process scientists call galactic cannibalism. Imagine a journey to a region of the sky, located in the direction of the constellation Virgo, hundreds of millions of light years away from the comforting familiarity of Earth. Here lies a massive collection of galaxies known as the Hubble 2029 cluster, all bound tightly together by gravity, dancing a slow waltz around a common center. And right in the very heart of that cluster, dominating everything around it like an ancient cosmic emperor sitting on a silent throne, sits a galaxy that defies all human comprehension. It goes by the rather unassuming catalog designation of IC 1101, but there is absolutely nothing ordinary about this giant. If our Milky Way, measuring 100,000 light years across, already seemed impossibly vast, IC 1101 shatters that scale entirely. This single galaxy is estimated to be somewhere around 4 to 6 million light years across. Let that immense scale wash over you for a gentle moment. It is roughly 40 to 60 times larger than our entire home galaxy. If you were to somehow place IC 1101 exactly where our Milky Way currently sits, it would not just gently engulf our galaxy. It would completely swallow our entire cosmic neighborhood. The Andromeda Galaxy, sitting 2.5 million light years away from us, would suddenly find itself buried deep inside IC 1101's sprawling body. The Triangulum Galaxy, another close neighbor, would also be instantly consumed, along with all the dozens of smaller dwarf galaxies that quietly orbit around us, such as the Large Magellanic Cloud and the Small Magellanic Cloud. They would all simply become tiny, insignificant components of this solitary giant's unfathomable structure. But the sheer physical size is just the beginning of the existential mystery. This gargantuan galaxy is estimated to contain an unfathomable 100 trillion stars. 100 trillion. To truly grasp the magnitude of that mind-bending number, consider that our own Milky Way holds perhaps 400 billion stars at its absolute maximum. This means IC 1101 has roughly 250 times more stars than our home galaxy. If you started counting the stars in IC 1101, counting exactly one star every single second without ever stopping to sleep or rest, it would take you over 3 million years just to count to 100 trillion. How does a structure of such incomprehensible magnitude come into existence? Does it not challenge our human concept of an orderly, perfectly designed creation? The truth is both beautifully poetic and deeply terrifying. IC 1101 did not grow to its enormous size through a peaceful, deliberate process of solitary starbirth. It became a monster through billions of years of relentless cosmic violence and gravitational domination. As the largest and most massive galaxy in its incredibly dense cluster, it sits at the deep gravitational center of absolutely everything around it. When smaller galaxies venture too close to this immense gravitational well, they are inevitably trapped by its inescapable pull. Over millions of years, they spiral inward, their delicate structures getting pulled and stretched by crushing tidal forces. Stars get ripped out of their normal orbits, and long, ghostly ribbons of stars known as tidal tails get drawn out into the dark space, marking the silent violence of the cosmic interaction. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its ancient history. 76 times, another substantial galaxy fell into this cosmic giant and was completely absorbed into its massive body, forever losing its individual identity in the dark. And those are only the major mergers. Countless smaller dwarf galaxies have also been consumed, swallowed up so easily that they barely registered as a meal for this enormous predator. The evidence for this cannibalistic history is permanently written in the very shape and structure of the galaxy itself. IC 1101 looks absolutely nothing like the beautiful, spiraling pinwheel of the Milky Way. It has no delicate arms, no neat, organized structure. It is what astronomers formally call an elliptical galaxy, presenting a smooth, oval-shaped, almost featureless appearance to the universe. The violent gravitational chaos of dozens of major mergers has completely destroyed any delicate spiral structure it might have once possessed, mixing all the hundreds of trillions of stars together into a massive, randomized distribution. It is precisely like someone vigorously mixing ingredients in a giant cosmic bowl, erasing all the intricate patterns that existed before the chaos began. This staggering reality asks a very profound question of the mindful observer. If the universe is the product of perfect order and gentle harmony, why is its most massive creation the direct result of continuous destruction, collision, and chaos? The paradox only deepens when we look even closer at this staggering giant. Despite containing an unfathomable 100 trillion stars, IC 1101 is actually a dying galaxy. It is a massive, ancient kingdom with absolutely no future generations to carry on its cosmic legacy. The stars within it are almost entirely old, consisting mostly of red giants or yellow stars, which are ancient stellar objects that have already burned through the vast majority of their nuclear fuel. Very few, if any, new stars are being born inside this immense structure. This might seem profoundly strange at first. With so much mass and countless stars, you might naturally expect IC 1101 to be a vibrant, glowing hotbed of stellar birth. But we must always remember exactly how it grew to be so large in the first place. Every single time it aggressively consumed another nearby galaxy, it also completely consumed that falling galaxy's vital supply of interstellar gas, which is the necessary raw fuel for any new star formation. Over billions of years of relentless galactic cannibalism, the violent mergers heated the existing gas to extreme temperatures, making it expand rapidly and escape the galaxy entirely, or compressing it so violently that it all formed into new stars at once in brief bursts of stellar activity. Either way, the final melancholic result is a sprawling galaxy that has completely run out of the raw material needed to create any new life. What remains today is a quiet, exhausted giant slowly and inevitably fading into the endless cosmic night. The ancient stars that exist there right now will continue to shine their fading light for billions of years to come, but as they eventually burn out, grow cold, and die one by one, there will be no delicate stellar nurseries, no new generations to replace them in the vast dark. It sits perfectly still in the dead center of its cluster, massive, powerful, and utterly magnificent, but also rapidly approaching the inevitable end of its active life. There is a profound poetry in this scientific realization. The largest object of its kind, built entirely through eons of consuming its galactic neighbors, ultimately starves its own self of the very ability to renew its own existence. This challenges our human desire for endless growth and eternal vitality, gently reminding us that even on the grandest scales imaginable, everything has a season, a definite beginning, and a quiet, inevitable end. As we drift softly through the vast, empty spaces of this contemplative journey, we must recognize the deep humility that naturally comes from understanding our tiny place in this ancient story. The gentle light we see from IC 1101 today left that dying giant over 1 billion years ago. It has been traveling in utter, profound silence through the absolute void of space for more than 1 billion years, just to eventually reach the delicate glass mirrors of our earthly telescopes. When that traveling light first began its long journey across the endless cosmos, life on our small blue planet was still mostly composed of simple, single-celled organisms floating aimlessly in primordial seas. Complex animals had not yet even evolved, and the mighty dinosaurs would not appear on the Earth for another several 100 million years. Every major event in human history, every triumph, every tragedy, every great civilization that has risen and quietly fallen, happened while that single beam of light was still quietly crossing the unimaginable, freezing emptiness between the galaxies. This staggering temporal contrast between our incredibly brief human lives and the deep geological time of the universe can sometimes feel overwhelming, but it is also a source of immense intellectual safety and inner peace. It gently tells us that we are an integral part of a story much larger than our daily worries, a grand narrative written in ancient gravity and fading starlight across billions of years. We may be remarkably small, but our unique capacity to wonder, to consciously observe, and to scientifically piece together the deep history of a dying galaxy 1 billion light-years away is nothing short of an absolute miracle of existence. We are the awakening consciousness of the cosmos, slowly opening our eyes in the dark, looking out at the fading embers of an ancient, chaotic giant, and finding breathtaking beauty in its silent demise. The universe may not always make perfect sense to our earthly intuition, and its methods of creation through violent galactic mergers may challenge our human ideas of divine perfection. But within that very mystery lies an infinite invitation to keep exploring the unknown. Rest your busy mind in this vastness. Let go of the need for absolute certainty, for there are still much deeper secrets hiding in the very core of this cosmic giant, just waiting to be revealed in the quiet dark. Have you ever tried to imagine what true nothingness feels like? We often think of empty space as a vast, quiet canvas where the gentle light of ancient stars paints the ongoing story of the cosmos. But what happens when matter becomes so incredibly dense, so overwhelmingly massive, that it literally tears a hidden hole in the fabric of reality itself? The universe is filled with paradoxes that gently challenge our understanding of existence, but none is more profoundly mysterious than the concept of a black hole. We naturally assume that the most powerful forces in the universe must be loud, bright, and impossible to ignore. Yet the absolute masters of the cosmic landscape hide in perfect silence, cloaked in an infinite darkness that not even a single photon of light can ever escape. When we peer into the deepest shadows of the ancient cosmos, we find that at the heart of almost every grand galaxy lies a sleeping leviathan, a supermassive black hole that silently dictates the gravitational fate of billions of stars. Our own Milky Way harbors one such entity, a quiet giant, known as Sagittarius A star, which holds a mass roughly 4 million times that of our Sun. It sits gently at the center of our galactic home, an invisible anchor in the swirling cosmic sea. If you are finding a sense of peace in these explorations of the vast and mysterious universe, I want to take a brief moment to welcome you. I am Theodore, the researcher, your companion on this quiet journey through the infinite. I have gently noticed that exactly 71% of the individuals who join us on these contemplative voyages have not yet subscribed to the channel. If our shared exploration of the cosmos brings you a sense of calm and wonder, please consider taking a moment to subscribe. It is a small gesture that helps us immensely, ensuring we can continue to wander through the beautiful mysteries of the universe together. Returning to our journey, we must travel back to the heart of the Abel 2029 cluster, to the very core of the galactic behemoth known as IC 1101. If the black hole at the center of our Milky Way is a quiet anchor, the entity lurking at the center of IC 1101 is a cosmic monster of truly mythological proportions. The central black hole of the Andromeda Galaxy, our nearest large neighbor, contains somewhere between 100 million and 200 million solar masses, which is already a staggering figure. But the black hole at the center of IC 1101 exists in a completely different category of reality. Scientists estimate that this single, unfathomable entity contains somewhere between 40 billion and 100 billion times the mass of our Sun. Let us pause for a moment to let that number gently settle into your mind. This solitary black hole possesses perhaps 25,000 times more mass than the black hole at the center of our entire Milky Way galaxy. It is a concentration of matter so profound that it utterly defies all human logic. To truly appreciate just how massive this is, imagine if you could somehow weigh our entire Earth. You would find it has a mass of about 6 trillion kilograms. That sounds like an astronomical amount until you gently compare it to our Sun, which is roughly 330,000 times more massive than Earth. Our Sun is a fairly ordinary star, neither particularly large nor particularly small by the standards of the cosmos. Now, take the mass of our Sun and multiply it by 50 billion. That is approximately how much mass is packed into the supermassive black hole at the center of IC 1101. And here is the most staggering paradox of all. All of that incomprehensible mass is compressed into a region of space from which absolutely nothing can ever escape. The gravitational pull at the event horizon, the absolute boundary of the black hole, is so intense that even light itself, the fastest entity in the universe, cannot break free from its grasp. It is an abyss of perfect, unbreakable silence. The physical size of a black hole's event horizon depends entirely on its mass. For a black hole containing 50 billion solar masses, the event horizon would have a radius of roughly 150 billion kilometers. That might sound enormous, and indeed it is, but remember that this is a region containing 50 billion times the mass of the Sun, compressed into what is essentially an infinitely small point at the very center. The event horizon is simply the invisible boundary beyond which escape becomes forever impossible. To put this staggering scale into a perspective we can almost grasp, consider our entire solar system, from the burning surface of our Sun all the way to the distant, icy orbit of Neptune. Our cosmic neighborhood is about 9 billion kilometers across. The event horizon of IC 1101's central black hole is roughly 16 times larger than our entire solar system. If you were to somehow place this terrifyingly beautiful monster exactly where our Sun is right now, its event horizon would extend well beyond the cold orbit of Pluto, completely engulfing everything we have ever considered our cosmic home. What would it truly be like to venture near this monstrous anomaly? The physics of such extreme environments are bizarre, highly counterintuitive, and deeply humbling. Time itself would pass differently near the event horizon compared to the quiet space far away. If someone were falling toward the black hole, they would perceive the outside universe speeding up, watching millions of years of cosmic history flash by in a brilliant instant. Conversely, an outside observer watching that person fall would see them slow down, appearing to gently freeze in place as they approached the boundary, their image fading away into the dark, but never seeming to actually cross the horizon. Inside the event horizon, the normal rules of reality break down entirely. All possible directions lead inexorably toward the singularity at the center. Space and time themselves become so drastically warped that the very concept of escaping becomes utterly meaningless. The singularity, a point of theoretically infinite density, would tear apart anything that fell in, gently stretching it into long, thin strands through a strange process that physicists have playfully nicknamed spaghettification. But here is the most remarkable and poetic truth about this specific cosmic giant. Despite its enormous size, its unfathomable mass, and its terrifying properties, the supermassive black hole at the center of IC 1101 is currently relatively quiet. It is not actively devouring huge amounts of matter. There is no brilliant, swirling accretion disk of doomed stars blazing around it. There is no powerful jet of radiation shooting into the deep space at nearly the speed of light. The black hole is simply there, waiting in the endless dark, because it has already consumed most of the material that was easily within its immense gravitational reach. This profound quietness is directly related to the very same melancholic phenomenon that has stopped IC 1101 from forming new stars. Most of the vital gas in the galaxy has already been used up, either blown away or locked into ancient, dying stars. And without a steady stream of gas falling toward the center, the black hole has very little left to eat. Occasionally, a wandering star might venture too close and get torn apart, providing a brief, brilliant meal for the sleeping giant. But these violent events are increasingly rare. The black hole, much like the sprawling, exhausted galaxy that hosts it, is a giant in repose, immensely powerful, but utterly dormant. It stands as a silent monument to a violent past, a cosmic tombstone marking the center of the largest known concentration of stars in the universe. There are still faint, ghostly traces of the black hole's past activity. Astronomers have detected a specific radio source at the galaxy's center, designated as PKS 508 plus 059, which comes from relativistic jets, streams of particles that were once accelerated to nearly the speed of light and ejected from the vicinity of the black hole. These ancient jets were powered by the black hole's rotation and intense magnetic fields, and they carved out enormous empty cavities in the surrounding hot gas. Images from sensitive X-ray telescopes show these cavities clearly. They are gigantic bubbles of very hot, very thin gas blown outward by the sheer energy released near the black hole during its more active youth. Some of these invisible bubbles are millions of light years across, serving as a silent testimony to the chaotic periods in the deep past when the black hole was much more active than it is today. The energy required to inflate these massive bubbles is truly staggering, roughly equivalent to the total energy output of billions of stars burning over millions of years. This intricate, delicate balance between supermassive black holes and their host galaxies is one of the most mysterious areas of modern astrophysics. Scientists now believe that supermassive black holes play a crucial role in regulating galaxy growth and evolution. When gas flows toward a galaxy's center, the black hole can release enough energy to heat that gas and push it outward, preventing it from forming stars. This creates a kind of thermostat effect that helps determine the final size and properties of galaxies. In the case of IC 1101, this feedback may be partly responsible for the galaxy's current state. The black hole helped shut down the birth of new stars by heating gas and preventing it from cooling and collapsing. The giant galaxy and its giant black hole have finally reached a quiet equilibrium, each one having deeply shaped the other over billions of years of shared violent evolution. It is a cosmic tragedy written in gravity and time, a story of endless consumption that ultimately ends in a beautiful, profound stillness. As we contemplate this sleeping giant, we are reminded that even the most powerful entities in the universe eventually find peace in the quiet dark. We are tiny observers floating in an infinite ocean of mystery, trying to comprehend scales that were never meant for our human minds. Yet, in our gentle persistence, we uncover the hidden mechanics of reality. The universe invites us to look past our fears of the dark unknown, revealing that within the most terrifying gravitational anomalies lies a profound, ancient beauty. We will carry this sense of wonder forward as we continue our journey, stepping ever deeper into the silence, seeking the calm truth hidden within the fabric of space and time. Have you ever considered how the most profound and violent events in the entire universe are completely invisible to our human eyes? Yet they send quiet, unseen ripples through the very fabric of reality itself. When we look up at the calm night sky, we imagine space as a fixed, unchanging stage where the cosmic drama gently unfolds. We think of space and time as a rigid, empty container, but modern physics reveals a much more mysterious and fluid truth. Space is not an empty void. It is a dynamic, stretching, and bending fabric, and when the most massive objects in the cosmos interact, they pluck this invisible fabric like the strings of a cosmic cello, sending waves of pure gravitational energy out into the infinite dark. As we explore the hidden history of the largest galaxy ever discovered, we must look beyond what shines and learn to understand what ripples in the silence. If you are finding a moment of quiet peace and intellectual safety in this exploration of our magnificent universe, please allow me to briefly welcome you. I am Theodore, the researcher, your gentle companion on this infinite journey through the cosmos. I have noticed that 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find calm and a sense of connection to the greater mysteries, please consider taking a gentle moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together. Now, let us return to the sleeping giant, the supermassive black hole at the center of the galactic behemoth, known as IC 1101. To understand how this central monster grew to contain 50 billion times the mass of our Sun, we must imagine the invisible ballet of galactic mergers. Over the course of IC 1101's long cannibalistic history, its central black hole has been fed again and again. Every single time this giant galaxy consumed another star city, it also inevitably consumed the central black hole from that falling galaxy. The two processes fed beautifully into each other, creating a profound feedback loop that eventually produced both the largest known elliptical galaxy and one of the most massive black holes in existence. But the process by which two supermassive black holes merge is not a simple, instantaneous collision. It is a deeply fascinating, violent, and unimaginably slow dance that takes place over millions of years. When two massive galaxies initially collide, their central black holes do not immediately find each other in the chaotic dark. They are initially separated by vast, sprawling distances and surrounded by billions of swirling stars. But as the merger slowly progresses, the gravitational friction with the surrounding sea of stars acts as a gentle drag, causing the two black holes to inevitably spiral inward toward the new gravitational center of the combined, newly merged galaxy. Eventually, the two dark behemoths get close enough to form a binary system, locking into a deadly, inescapable orbit around each other. As they orbit, they disturb the very fabric of space and time, losing precious energy through the emission of gravitational waves. These waves are literal ripples in the fabric of space-time itself, carrying immense energy away from the binary system and causing their mutual orbit to gradually shrink. The black holes spiral closer and closer together, orbiting faster and faster in the silent dark, until finally they merge in a catastrophic event that releases enormous amounts of pure, invisible energy. When two supermassive black holes merge, the gravitational waves they produce are among the most powerful and energetic events in the entire universe. The final moment of merger actually releases more energy than all the shining stars in a typical galaxy combined, although this staggering energy is released almost entirely in the form of gravitational waves rather than visible light. These invisible ripples travel outward at the exact speed of light, gently stretching and squeezing space itself as they pass through the cosmos, eventually washing over our tiny Earth billions of years later. For most of human history, we were completely deaf to this cosmic symphony. We have only very recently developed the miraculous technology required to detect these subtle gravitational waves. The very first direct detection came in the year 2015, when the LIGO observatories gently measured the invisible ripples from two much smaller stellar mass black holes, merging about 1 billion light-years away. Since that groundbreaking moment, dozens of gravitational wave events have been quietly observed, opening up an entirely new, non-visual way of studying the deep universe. We are no longer just looking at the cosmos. We are finally listening to its most ancient and violent tremors. Future gravitational wave detectors, like the planned LISA mission that will fly in the quiet vacuum of space, perhaps in the 2030s, will be sensitive enough to detect the monumental mergers of supermassive black holes. When this magnificent instrument launches, it might actually detect events very similar to the ancient mergers that slowly built up the central black hole of IC 1101. We will literally be able to listen to the universe as giant black holes collide, adding a profound new sense to our astronomical toolkit and bringing us one step closer to understanding the invisible architecture of reality. The central black hole of IC 1101 has experienced dozens of such dramatic mergers over its incredibly long history. Each merger quietly added more mass and fundamentally altered the black hole's invisible spin. But the process of multiple massive mergers also deeply affected the surrounding galaxy itself, as the merging black holes acted like a cosmic slingshot, violently flinging billions of stars outward through intense gravitational interactions. This gentle but relentless scattering is probably the main reason why the core of IC 1101 is so incredibly large, yet relatively faint to our telescopes. A fascinating study conducted in the year 2017, using crystal-clear images from the Hubble Space Telescope, carefully measured the galactic core and found that it stretches across nearly 14,000 light-years. That means just the central core of IC 1101, not the whole sprawling galaxy, but merely its innermost region, is vastly bigger than most entire dwarf galaxies in the universe. This core alone contains far more stars than most normal galaxies possess in their entirety. Yet, repeated black hole mergers have scattered many of those stars away from the very center, creating a core profile that is highly unusual for galaxies of this magnificent size. It is a massive, slightly hollowed-out center, a quiet monument to the invisible gravitational violence that shaped it over billions of years. Now, I want to gently take you on a thought journey to help you truly appreciate the unimaginable scale of what we are discussing, to move beyond simple numbers and feel the vastness in your very soul. Imagine, if you will, that you could somehow travel from one outer edge of IC 1101 all the way to the other. You would need to cross a distance of somewhere between 4 and 6 million light years. Remember that light, the absolute fastest entity in the cosmos, travels at about 6 trillion miles per year. Even at that incomprehensible, mind-bending speed, simply crossing IC 1101 would take millions of years. But let us try another, more human comparison to ground this reality. The Voyager 1 spacecraft, successfully launched by NASA in the year 1977, is the absolute fastest human-made object ever to leave the comforting embrace of our solar system. It is currently traveling through the interstellar dark at about 38,000 miles per hour relative to our Sun. At that staggering speed, Voyager 1 would still take about 80,000 years just to reach the absolute nearest star to our Sun, Proxima Centauri, which is a mere 4 light-years away. To cross our entire Milky Way galaxy at Voyager, one's impressive speed would take about 2 billion years. And to cross the majestic expanse of IC 1101, you would need somewhere between 80 billion and 120 billion years. Let that immense scale wash over your mind for a quiet moment. That is vastly more time than our entire universe has even existed. Even with our most advanced, fastest spacecraft, crossing this single, solitary galaxy would be completely impossible within the current lifespan of creation. Here is another gentle way to visualize it. If you could somehow shrink our entire Milky Way down to the small, familiar size of a dinner plate, measuring about 10 inches across, then IC 1101 would be roughly the size of a large swimming pool. Our entire galaxy, containing all of its hundreds of billions of stars, the delicate spiral arms where we make our home, the history of our planet, and every human who has ever lived, would be just a tiny, fragile dish floating in a vast, overwhelming sea. Or consider this beautiful reality. Light from IC 1101 has traveled through the cold, empty vacuum for over 1 billion years, just to reach us. In all that immense time, ancient light has been continuously streaming away from this giant galaxy in absolutely every direction. Every single second, IC 1101 radiates enough light to travel about 186,000 miles. Over 1 billion years, that light has traveled 1 billion light years, which is roughly 6 billion trillion miles. And it is only now, at this very moment, just arriving at our delicate telescope lenses. Ancient photons that first left their home galaxy when our own Earth was still in its very early stages of developing complex life. The deep contemplation of such scales naturally strips away our worldly anxieties, replacing them with a quiet, productive humility. When we realize that crossing a single galaxy would take longer than the universe has been alive, our daily worries suddenly seem infinitesimally small. We are floating in an ocean of ancient light, guided by the unseen ripples of gravitational waves, surrounded by mysteries that gently invite us to keep asking questions. We do not need to feel small in a frightening way. Rather, we should feel a profound, peaceful connection to the grand architecture of reality. The universe is incredibly vast, and yet you are here, a conscious piece of that universe, capable of understanding its immense beauty. This knowledge is not a burden, but a quiet gift. It is an infinite path of exploration, a journey of the mind that never truly ends. When we look out into the dark, We are not just seeing distant stars. We are witnessing the magnificent result of billions of years of cosmic history, a slow and beautiful unfolding of physical laws that eventually gave rise to our own curious minds. The silent ripples of gravitational waves passing through our bodies right now carry the ancient stories of black holes dancing in the dark, whispering secrets of a universe that is far more dynamic, interconnected, and mysterious than we ever dared to imagine. Let us rest here for a moment, suspended in the quiet dark, before we continue to explore the magnificent tools and the beautiful human ingenuity that allow us to see across these unfathomable distances. Have you ever paused in the quiet stillness of the night, looked up at the scattering of pale stars, and wondered how it is physically possible for us to know anything at all about the distant cosmos? It is a profound existential mystery that often goes entirely unnoticed in our busy daily lives. We are fragile, temporary beings bound to a small, rocky planet orbiting a perfectly ordinary star, yet our minds have somehow managed to reach out across the infinite, freezing void to measure, weigh, and comprehend objects so incomprehensibly far away that their light left before complex life even existed on our world. The story of the discovery and study of the largest galaxy we have ever found, IC 1101, is not just a tale of ancient cosmic violence. It is an incredibly beautiful testament to human ingenuity, persistent curiosity, and the gentle, cumulative power of scientific progress. Before we dive into the magnificent tools that allow us to pierce the veil of the dark universe, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this journey through the ancient mysteries of space. I have noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find a sense of peace and a connection to the greater wonders of reality, please consider taking a gentle moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together. Now, let us return to the miraculous story of how we have learned to see the invisible. The remarkable journey of how we observe distant galaxies begins with the humble development of telescopes themselves, instruments that act as mechanical extensions of our natural human wonder. When the brilliant astronomer Galileo first turned a primitive, handcrafted telescope toward the gentle night sky in the year 1609, he could clearly see the ancient craters scarred into the surface of our moon, and he could watch the small, quiet moons of Jupiter dancing in their orbits. But the distant galaxies, those sprawling island universes containing hundreds of billions of stars, were completely invisible to him. They were simply too profoundly faint, their ancient light far too dim and exhausted after traveling across millions of light years to be detected by the very small, simple glass lenses of the earliest telescopes. Over the next 300 years, human curiosity drove the relentless creation of larger and more sophisticated instruments. Bigger, carefully polished mirrors could gather more of the scarce, falling starlight, gently allowing astronomers to peer deeper into the darkness and see much fainter objects. By the time the German-born British astronomer William Herschel first discovered IC 1101 in the year 1790, he was systematically scanning the night sky, using what was then an incredibly impressive telescope featuring a polished mirror roughly 18 inches across. Herschel was one of the absolute greatest astronomers of his era, dedicating his life to meticulously cataloging thousands of celestial objects that no human eyes had ever documented before. Yet, on June 19th of that year, when he pointed his instrument toward the constellation Virgo, all his 18-inch mirror could reveal was a faint, fuzzy blob of light. He had absolutely no way of knowing what he was actually looking at. The technology simply did not exist to measure how far away this quiet object was, nor did the scientific understanding exist to recognize that it was an entire, separate galaxy containing 100 trillion stars. Herschel gently logged it as another mystery, a nebula, and moved on, leaving the true nature of that faint smudge to remain a cosmic secret for over a century. The real, staggering breakthroughs in our cosmic comprehension arrived in the 20th century, driven by the need to overcome our own planet's gentle, protective blanket. Earth's atmosphere, while absolutely essential for breathing and sustaining all life as we know it, is a major, frustrating obstacle for astronomy. The atmosphere is constantly moving, shifting, and shimmering, which is precisely why the stars appear to gently twinkle when we look at them from the ground. This constant twinkling heavily blurs and distorts the delicate images that ground-based telescopes try to capture, severely limiting how clearly they can see into the distant cosmos. Furthermore, our atmosphere entirely absorbs certain wavelengths of light, completely preventing X-rays and much of the ultraviolet and infrared spectrum from ever reaching the surface of the Earth. To truly understand a monster like IC 1101, we had to leave the comforting embrace of our planet. Everything fundamentally changed with the historic launch of the Hubble Space Telescope in the year 1990. Floating silently in the cold vacuum above the shimmering atmosphere, Hubble could finally capture images of the deep universe with incredible, breathtaking clarity. Over the decades since its launch, Hubble has observed IC 1101 multiple times, peeling back the darkness to reveal exquisite details about its massive, scoured core, its surrounding halo of ancient stars, and its complex relationship to the countless other galaxies caught in its gravitational web. The historic 2017 study that meticulously measured the enormous core of this galaxy relied heavily on the crystal-clear data provided by Hubble. But the pursuit of cosmic truth requires us to look at the universe through many different kinds of eyes. More recently, astronomers have utilized a beautiful variety of other space telescopes to study IC 1101 at entirely different, invisible wavelengths of light. The Chandra X-ray Observatory has gently peered into the void to map the incredibly hot, superheated gas that fills the galaxy cluster surrounding the giant, revealing the violent, invisible environment in which it lives. The Spitzer Space Telescope observed the galaxy in the quiet glow of infrared light, peering straight through the obscuring clouds of cosmic dust to carefully study the ancient, cooler stellar populations hidden within the massive elliptical body. Each new telescope, observing at different wavelengths, gently adds another crucial piece to the grand cosmic puzzle. And the march of human ingenuity continues. Ground-based observatories have improved dramatically, now using a miraculous technique called adaptive optics, which uses deformable mirrors and bright lasers to perfectly correct for the atmosphere's shimmering distortion in real time. The resulting images approach the pristine quality of space-based observations. Looking toward the future, the magnificent James Webb Space Telescope, which launched into the dark in late 2021, has already begun observing the most distant galaxies with absolutely unprecedented sensitivity in infrared light. Meanwhile, the extremely large telescope, currently under ambitious construction in the high mountains of Chile, will feature a staggering mirror measuring nearly 130 feet across when it finally sees first light in the late 2020s. These magnificent instruments are grand monuments to our unyielding desire to understand the silent mysteries of the vast universe. Yet, seeing a distant galaxy is only half the profound mystery. The other half is figuring out exactly how far away it sits in the boundless dark. Distance is one of the most fundamental, crucial quantities in astronomy, but it is also one of the hardest things to measure. How do you accurately tell how far away something is when you can never travel there to stretch out a measuring tape? For relatively nearby stars, astronomers use a simple, elegant geometric technique called parallax. As our Earth orbits the Sun over the course of a year, our perspective on nearby stars changes ever so slightly against the fixed background of more distant stars. By measuring this tiny shift, astronomers can calculate the exact distance. However, for objects as incredibly remote as IC 1101, the parallax shift is far too tiny to measure, even with our absolute most precise instruments. To bridge this unfathomable gap, astronomers rely on a beautiful concept called the cosmic distance ladder, a sequential series of observational techniques that carefully build upon each other. One crucial rung of this ladder involves the Cepheid variable stars, the very same pulsing stars Edwin Hubble used to prove the existence of other galaxies. By measuring their regular pulsation rate, astronomers can deduce their true intrinsic luminosity, and by comparing that to how bright they appear to us, they calculate the distance. But IC 1101 is too impossibly distant, even for this elegant technique. Individual Cepheid stars are far too faint to detect across such a vast, empty gulf. For these extreme, mind-bending distances, astronomers must rely on much brighter, more violent cosmic beacons known as standard candles. One of the most important of these is a specific type of exploding star called a Type 1, a supernova. These catastrophic explosions occur when a dense white dwarf star accumulates too much stolen matter from a companion star and detonates in a thermonuclear blast of staggering proportions. Because the physical conditions required for this detonation are remarkably similar from one supernova to another, they all reach roughly the exact same peak brightness. By observing how bright one of these explosions appears from Earth, scientists can accurately estimate the distance to its host galaxy. Another profoundly elegant technique involves measuring the redshift of the ancient light itself. As the very fabric of the universe constantly expands, the light traveling through it from distant objects gets physically stretched out to longer, redder wavelengths. The more distant a cosmic object is, the more the universe has expanded since that light was first emitted, and therefore, the greater its redshift will be. By carefully measuring the redshift of the light arriving from IC 1101, astronomers have definitively determined that it sits at a staggering distance of roughly 1.04 billion light-years away from us. This precise measurement, delicately combined with observations of the galaxy's apparent size in our sky, allows researchers to calculate its true physical diameter and estimate the mass of its 100 trillion stars. There is an incredibly beautiful, melancholic philosophical truth hidden within these staggering measurements. When we look at IC 1101, we are not seeing the massive galaxy as it is today. Because of the absolute speed limit of light, we are seeing the galaxy exactly as it was over 1 billion years ago, when the photons we gently capture today first began their long, silent journey toward our solar system. 1 billion years ago, our Earth was a profoundly different, alien place. Complex animal life had not yet evolved. The blue planet was quietly populated by single-celled organisms, and the continents were gathered in unrecognizable configurations. During all the time since then, the light from IC 1101 has been tirelessly traveling through the cold vacuum of space, occasionally passing through invisible clouds of intergalactic gas or being bent ever so slightly by the gravity of intervening objects. In a very real, literal sense, we are cosmic archaeologists. Every single observation of the deep universe is a profound look backward in time, a quiet glimpse into the ancient history of creation rather than the present moment. We have absolutely no way of knowing what IC 1101 looks like at this very second. That new information will not reach our world for another billion years. This time delay is a beautiful limitation that allows us to study cosmic evolution directly, tracing the majestic story of the universe from its violent, chaotic past to its quiet, mysterious future. Have you ever walked outside on a moonless night, looked up at the vast expanse of the sky, and felt an overwhelming sense that the darkness itself was alive, holding secrets far heavier than the stars? We are naturally drawn to the light. When we look at the universe, our eyes and our instruments seek out the brilliant fires of stars, the glowing clouds of ancient gas, and the bright, swirling disks of distant galaxies. We assume that because light is what we can see, light is what matters most. But the cosmos holds a gentle, humbling paradox that fundamentally alters our understanding of reality. The vast majority of the universe is completely invisible, made of substances and forces that do not emit, absorb, or reflect any light whatsoever. The shining stars, the majestic galaxies, the planets, and even our own bodies represent merely a tiny, luminous fraction of what actually exists. As we continue to study the gargantuan form of IC 1101, we must inevitably confront the profound mystery of the unseen, the invisible architecture that holds this cosmic giant together, and the mysterious anti-gravity that threatens to eventually tear the universe apart. If you are finding a quiet sanctuary in these deep explorations of the ancient cosmos, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this journey through the endless wonders of space. I have gently noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find a sense of peace and a connection to the greater mysteries of reality, please consider taking a moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together. Now, let us close our eyes to the light for a moment and explore the profound weight of the invisible universe. When astronomers calculate the size and the impact of a galaxy as unimaginably large as IC 1101, they cannot rely on starlight alone. If you were to painstakingly add up the mass of all 100 trillion stars glowing within this magnificent elliptical galaxy, and then calculate exactly how much gravitational pull those burning spheres should exert, you would immediately encounter a staggering mathematical problem. Then, if you were to measure how fast the stars are actually orbiting in the outer, fading parts of the galaxy, which tells you exactly how much gravity is truly present to keep them from flying off into the void, the two numbers simply do not match. There is vastly more gravity acting upon the galaxy than the visible matter can possibly account for. This mathematical discrepancy is not a minor error. It is a fundamental feature of our universe. The beautiful, poetic solution to this paradox is that galaxies are completely surrounded by vast, invisible halos of a mysterious substance that we call dark matter. Dark matter is one of the greatest, most profound mysteries in all of modern physics. We cannot see it with our eyes, and our most advanced telescopes cannot detect its light because it simply does not interact with the electromagnetic spectrum. It does not shine, it does not reflect, and it does not cast a shadow. Yet, we know with absolute certainty that it exists because its immense gravitational influence shapes the very structure of the cosmos. In a typical spiral galaxy like our own Milky Way, dark matter accounts for roughly 90% of the total mass. The brilliant stars, the swirling gas, the ancient dust, and all the planets that we can actually observe are just a tiny, fragile fraction of what is truly there. They are like the white caps on the surface of a deep, unfathomable ocean. For a cosmic monster like IC 1101, the invisible reality is correspondingly enormous. Scientists estimate that the total mass of IC 1101, when fully including its massive dark matter halo, could be as staggeringly high as 1,100 trillion solar masses. To put that immense figure into perspective, it is about 100 times more massive than our entire Milky Way galaxy. This dark matter halo extends incredibly far beyond the visible glowing stars of the galaxy. While the stellar body of IC 1101 is already an astonishing 4 to 6 million light-years across, the invisible dark matter halo likely extends even further into the dark. Some scientific models gently suggest that this invisible scaffolding could reach out tens of millions of light-years, making the complete, true structure of IC 1101 and its gravitational surroundings truly mind-boggling in its sheer scale. Understanding dark matter remains one of the absolute biggest challenges facing human physics today. We know it is there because of the way it gracefully bends light and holds spinning galaxies together, but we do not know what it is actually made of. Many scientists believe it consists of some kind of exotic particle that simply does not interact with normal everyday matter, a ghostly particle we have not yet managed to detect directly. Huge, incredibly sensitive experiments are currently underway deep underground around the world, quietly waiting in the dark, trying to catch a single dark matter particle as it passes harmlessly through the Earth. So far, none have succeeded. The undeniable existence of dark matter shows us that even our understanding of something as monumental as IC 1101 is profoundly incomplete. We can see the trillions of stars. We can carefully measure their ancient light. But 90% of what makes IC 1101 the massive, dominating giant it is remains completely invisible to us, detectable only through its silent gravitational influence on the things we can see. But the mystery of the invisible universe does not end with dark matter pulling things together. It extends to an even more terrifying and beautiful force that is pushing the universe apart. To understand the ultimate fate of IC 1101, we must look beyond its immediate cluster and consider the grand, evolving structure of the entire cosmos. For most of the 20th century, astronomers naturally assumed that the expansion of the universe, which began with the Big Bang, was gradually slowing down. This made perfect, intuitive sense to the human mind. Everything in the universe is constantly pulling on absolutely everything else through the invisible force of gravity. You would logically expect all that immense gravitational attraction to act exactly like a cosmic brake, slowly and gently decelerating the expansion of space over billions of years. However, in the year 1998, two independent, highly dedicated teams of astronomers made a shocking, reality-altering discovery. They were carefully measuring the expansion rate of the universe by observing distant supernovas, using these incredibly bright exploding stars as standard candles to calculate vast cosmic distances. What they found was completely, utterly unexpected and defied all conventional logic. The universe was not slowing down at all. It was actually speeding up. Distant galaxies were moving away from us significantly faster than closer ones, and the overall rate of universal expansion was actively accelerating over time. This discovery was so profoundly unexpected that the brilliant astronomers initially thought they had made a mathematical error. But as more detailed data came in from more supernovas and from a variety of other observations, the staggering result held firmly up against scrutiny. Something unseen was actively pushing the universe apart, forcefully counteracting the immense inward pull of gravity and causing the very fabric of space itself to expand at an ever-increasing runaway rate. Scientists gave this mysterious, repulsive force a poetic and enigmatic name: dark energy. Though the name tells us very little about what it actually is, we know that dark energy makes up about 68% of all the total energy in the entire universe. We know that it acts as a kind of silent anti-gravity, tirelessly pushing space apart rather than pulling it together. We also know that its profound effects become increasingly more important over vast stretches of time. As the universe expands and ordinary matter becomes more widely spread out in the growing void. But we simply do not know what dark energy is made of, where it ultimately comes from, or why it possesses the exact specific strength that it does. It might be an inherent, fundamental property of empty space itself, something deeply related to the cosmological constant that Albert Einstein once famously proposed and then later called his biggest blunder. It might be an entirely new, undiscovered kind of energy field that quietly pervades the entire universe. It might even be a gentle sign that our deeply held understanding of gravity is fundamentally incomplete and desperately needs to be revised. Whatever it truly is, dark energy is currently reshaping the absolute future of the cosmos, dictating the final chapter of every single object within it. What we do know with absolute certainty is that dark energy is steadily carrying the universe toward a remarkably lonely future. As the fabric of space expands faster and faster, distant cosmic objects recede from us at ever-increasing speeds. There is a strict, absolute limit to how fast light can travel through space, but there is absolutely no theoretical limit to how fast the space itself can expand. Eventually, objects will be carried away from us by the relentless expansion of space at speeds that effectively exceed the speed of light, meaning their light will no longer be able to travel toward us fast enough to ever reach our eyes. When that melancholic moment happens, those distant galaxies will simply vanish forever behind an impenetrable cosmic horizon, slipping forever beyond our physical reach and our visual sight. For a massive, cannibalistic giant like IC 1101, this relentless acceleration holds a very specific, quiet tragedy. Its long, violent days of growth through galactic cannibalism are strictly numbered. As dark energy pushes the universe apart, the space between galaxy clusters grows ever wider. Eventually, there will simply be no more nearby galaxies left for it to capture and consume. IC 1101 will become profoundly isolated, a lonely, exhausted giant floating aimlessly in an ever-emptying universe, silently watching as one by one all the other distant galaxies simply fade from view into the absolute dark. The universe, which right now is a vibrant, bustling tapestry of intersecting lights and gravitational dances, will slowly transition into an archipelago of isolated islands separated by oceans of empty, expanding space that can never be crossed. This realization invites a deep, contemplative stillness. We are currently living in a privileged, beautiful epoch of cosmic history, where the universe is still close enough together to be seen, studied, and marveled at. We can still look out and see 2 trillion galaxies scattered across the dark. We can still witness the majestic scale of IC 1101. But this view is temporary. The cosmos is slowly pulling the curtains closed. Instead of feeling despair at this slowly approaching isolation, we should feel an immense, profound gratitude. We exist exactly at the right time to witness the grandeur of creation. We possess the unique, fragile consciousness required to look at the invisible dark matter that shapes the galaxies and the invisible dark energy that drives them apart. And to say, I see the mystery and I am a part of it. The darkness is not empty. It is full of ancient forces silently moving the stars, guiding the galaxies, and eventually bringing everything to a quiet, peaceful rest. Let us extend our contemplation for just another gentle moment. When we think about the 68% of the universe that is dark energy, and the roughly 27% that is dark matter, we suddenly realize that all the normal matter, the stars, the planets, the gas clouds, the comets, and every single human being makes up only about 5% of the total universe. We are truly the exception, a tiny, luminous minority in a cosmos dominated by the invisible and the unknown. This immense scale of the unseen universe serves as the perfect antidote to human arrogance. We cannot even perceive 95% of reality with our natural senses. We are like sailors trying to understand the depth of the ocean by merely observing the white foam on the crests of the waves. Yet, despite this profound limitation, we have used our intellect and our relentless curiosity to deduce the existence of the deep waters. We have mathematically mapped the invisible halo of IC 1101. We have measured the invisible acceleration of expanding space. We have found comfort in the realization that our ignorance is merely an endless invitation to learn more. The cosmic silence that surrounds us is not an empty void, but a vast, invisible structure of perfect, mathematical harmony. And as we continue our journey, we will see that even as this giant galaxy faces its ultimate isolation, it will do so with a breathtaking, poetic grace. Have you ever wondered what the cosmos will look like when the ancient fires finally begin to fade and the universe forgets how to shine? We construct our entire understanding of reality around the comforting presence of light and warmth. We wake up to the glow of our local star, and we drift to sleep beneath the gentle, scattered light of distant suns. It is difficult for the human mind to conceive of a reality where this perpetual illumination simply ceases to exist. We assume that because the stars have always been there in our night sky, they will remain forever an eternal monument to the grand design of the cosmos. But the universe is a continuous journey, not a static painting, and every journey must eventually navigate into the uncharted territories of the dark. The ultimate fate of the magnificent structures we have discovered is a profound mystery that requires us to stretch our imagination far beyond the limits of human time, into an era where the familiar universe slowly winds down into a perfect, infinite silence. If you are finding a quiet sanctuary in these deep explorations of the ancient cosmos, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this journey through the endless wonders of space. I have gently noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find a sense of peace and a connection to the greater mysteries of reality, please consider taking a moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together, uncovering the quiet truths hidden in the vastness of space. Now, let us turn our minds toward the incredibly distant future and witness the beautiful, melancholic fading of the greatest giant the universe has ever known. Let us paint a more detailed, contemplative picture of what this future looks like. We must remember that IC 1101 currently sits at the very heart of the Able 2029 galaxy cluster, completely surrounded by hundreds of other galaxies. These galaxies are tightly bound together by their immense mutual gravity, orbiting gracefully around their common center of mass. For the time being, this local gravity is strong enough to hold the massive cluster perfectly together against the relentless expansion of space. But in about 100 billion years, the invisible push of dark energy will have accelerated to the point where galaxies outside our local supercluster will begin to disappear entirely over the cosmic horizon. From the isolated perspective of IC 1101, the vast crowded sky will slowly start to empty. One by one, the distant galaxy clusters will quietly fade from view, their ancient light no longer able to reach across the rapidly expanding void. The observable universe, which currently contains a magnificent tapestry of about 2 trillion galaxies, will drastically shrink in the dark. Within the Able 2029 cluster itself, things will remain intimately connected for a while longer. The galaxies there are close enough and bound tightly enough that they will stay together even as the larger, grander universe empties out around them. Over the next several billion years, these remaining galaxies will continue to gently interact, merge, and evolve in the silence. IC 1101 might still quietly consume a few more of its smaller neighbors, growing slightly larger even as the rest of the universe slips away into the unreachable distance. But eventually, driven by the exact same gravitational friction that has defined its entire violent history, even the remaining galaxies within the cluster will merge together. The ancient processes that originally built IC 1101 will continue relentlessly, drawing the remaining galaxies toward the deep center, where they will be peacefully absorbed into an even larger, singular, combined structure. In the very long run, perhaps in several 100 billion years, absolutely all the galaxies in the Able 2029 cluster might merge into one single, enormous galaxy, one that is even more massive than IC 1101 is today. By that extremely distant time, however, the universe immediately beyond this supergalaxy will be terrifyingly empty. Absolutely no light from distant objects will be reaching the cluster anymore. The night sky, if any conscious observers still existed to look up at it, would show only the local stars of that single merged galaxy against a sprawling backdrop of flawless blackness. The rest of the cosmos would have slipped entirely beyond the cosmic horizon, forever unreachable and perfectly unknowable. This is the profound, quiet isolation that awaits IC 1101 and every other bound structure in the universe, entirely cut off from everything else by the relentless, invisible expansion of space. Each island of matter will be left completely alone with itself as the quiet eons roll by. But even this profound cosmic isolation is not the final fate of IC 1101. We must ask ourselves what happens to a magnificent galaxy in a universe that is slowly winding down toward its ultimate end. a state physicists call heat death. The answer is as magnificent as it is deeply melancholy. Over the next 100 trillion years, the trillions of stars currently burning in IC 1101 will slowly, inevitably, burn out. To understand this fading, let us walk gently through the process of stellar death in more detail, because the immense time scales involved are truly mind-boggling and demand our quiet respect. The most massive stars in the galaxy, the brilliant blue giants and supergiants, live fast and die incredibly young. They relentlessly burn through their nuclear fuel in just a few million years before exploding in violent supernovas. Any shining blue giants that IC 1101 might have once possessed burned out billions of years ago in the deep past. The galaxy today is entirely dominated by older, smaller, much longer-lived stars. The stars most similar to our own sun have average lifetimes of about 10 billion years. Our sun is roughly halfway through its long life, with about 5 billion years left before it swells into a massive red giant, gently sheds its outer layers as a beautiful, glowing nebula, and then finally fades away as a small, dense white dwarf. In the vast expanse of IC 1101, many sun-like stars have already completed this exact process, leaving behind silent white dwarf remnants. Others are still shining warmly in the dark, but over the next several billion years, they too will exhaust their fuel and quietly burn out. But the most numerous and resilient stars in any galaxy are the red dwarfs, tiny stars possessing only a small fraction of the sun's mass. Red dwarfs are the absolute quiet survivors of the cosmos. They burn their fuel so incredibly slowly that they can continue to shine for trillions of years. A tiny red dwarf born at the exact same time as our sun will still be shining brightly long after our sun has become a cold, dead white dwarf. In a mammoth structure like IC 1101, with its 100 trillion stars, there are untold, uncountable numbers of red dwarfs. These tiny, dim stars will be the absolute last lights to go out in the universe. For trillions of years after all the larger stars have died, the red dwarfs will continue to gently burn, providing the only faint light in an otherwise entirely darkening galaxy. But even the incredibly resilient red dwarfs have their ultimate physical limits. The very smallest red dwarfs, those with perhaps just 8% of our sun's mass, can slowly burn for up to 10 trillion years. That staggering span of time is about 700 times longer than the entire current age of our universe. But eventually, inevitably, even they will exhaust their precious hydrogen fuel and quietly fade into the absolute darkness. Scientists estimate that absolutely all star formation in the entire universe will effectively cease in about 100 trillion years. By that incomprehensibly distant time, the primordial gas and dust needed to make new stars will have been completely used up or dispersed far too thinly to ever collapse under gravity. No new stars will ever be born to replace the ones that have died. The magnificent era of starlight will simply be over. One by one, the 100 trillion ancient stars of IC 1101 will quietly wink out like fragile candles in a gentle breeze. The giant galaxy will grow dimmer and dimmer over time scales that make the entire current age of the universe seem like the mere blink of an eye. Where once there was a blazing inferno of stellar light, there will eventually be absolutely nothing but the cold, dark remnants of dead stars drifting silently through an ever-expanding void. The universe at this incredibly late stage will be a profoundly dark place, but it will not be an empty one. All those stellar remnants, the countless white dwarfs, the incredibly dense neutron stars, and the invisible black holes will still exist in the dark. They will continue to orbit endlessly through the massive, merged remnant of what was once IC 1101 and its cluster companions. The galaxy will become a silent ghost of its former self, populated entirely by the dense corpses of stars rather than by living, burning suns. There is a strange, profound beauty in this final state of existence. It reminds us that the blazing stars we see today are just a passing phase, a brief, beautiful flowering of energy and light between the intense chaos of the early universe and the perfect, cold quiet of the infinite future. When we deeply contemplate this ultimate silence, we are not meant to feel a sense of despair or existential dread. Instead, we should feel an overwhelming sense of wonder and profound gratitude that we exist right now in the brief cosmic spring, possessing the unique, fragile ability to gaze upon the light before it fades, to understand the magnificent mechanics of creation, and to witness the beautiful, fleeting majesty of the biggest galaxy ever discovered. Have you ever thought about what eternity truly means? We often use the word forever to describe the ancient mountains, the deep oceans, or the scattered stars in the night sky. We assume that even if the bright fires of the cosmos eventually burn out, the physical remnants of those celestial bodies will remain completely intact, floating silently in the endless void as eternal monuments to what once existed. But the universe is bound by laws of physics that gently dismantle even the most resilient, massive structures over unimaginable stretches of deep time. As we trace the final destiny of the largest galaxy ever discovered, we must look far beyond the fading of its very last red dwarf stars. We must embark on a contemplative journey into an era so profoundly distant that the very concepts of time and matter begin to lose their meaning. When the era of starlight finally concludes in IC 1101, the galaxy will be nothing more than a quiet, sprawling graveyard of stellar corpses. The white dwarfs, the neutron stars, and the black holes will continue their silent orbits in the vast dark. It might initially seem like this perfectly dark state could last for an infinite amount of time, a frozen, unending snapshot of a dead universe. Yet, even in this absolute darkness, the gentle, relentless forces of nature continue their quiet work of dismantling the cosmos. Over time, scales that make the previous trillions of years seem incredibly brief. Even these dense stellar corpses will begin to decay. The white dwarfs, which are the glowing, ultra-dense cores left behind by stars like our own sun, will slowly radiate their remaining heat away into the freezing vacuum of space. They will quietly cool down until they become what astronomers call black dwarfs, completely frozen objects that no longer emit any detectable light or heat whatsoever. This agonizingly slow cooling process takes an almost inconceivable amount of time to complete. A single white dwarf cools down to near absolute zero only after about 10 to the 15th power years, which is roughly 1 million billion years. Let that immense scale gently settle into your mind. That is about 100,000 times longer than the entire current age of the universe. If you are finding a quiet sanctuary in these deep explorations of the ancient cosmos, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this journey through the endless wonders of space. I have gently noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find a sense of peace and a connection to the greater mysteries of reality, please consider taking a moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together, uncovering the quiet truths hidden in the vastness of space. Now, let us continue our journey into the deep future. While the white dwarfs slowly fade into invisible black dwarfs, the incredibly dense neutron stars might face an even more profound dissolution. Physicists theorize that the fundamental building blocks of atomic nuclei, the protons themselves, might not be entirely stable over these unimaginable timescales. Some complex theories of particle physics gently predict that protons should eventually decay, literally breaking down into lighter subatomic particles and pure radiation, with a half-life of around 10 to the 34th power years, or even longer. If this profound theory holds true, then over unfathomably long spans of time, absolutely all the normal matter that makes up the neutron stars, the frozen planets, the black dwarfs, and whatever dust remains of IC 1101 will gradually, silently dissolve into a thin mist of radiation. The very physical substance of the universe will simply evaporate into the endless void, leaving absolutely nothing behind but wandering photons and elementary particles spreading out through an ever-expanding, ever-cooling dark. The solid reality we rely on is just a temporary arrangement of energy, a fleeting moment of structure in an otherwise dissolving cosmos. But what about the black holes? What happens to the gargantuan monsters like the 50 billion solar mass behemoth sitting at the core of IC 1101? Surely, these infinitely dense gravitational traps must last forever. Yet, one of the most brilliant minds in human history, the physicist Stephen Hawking, mathematically proved that even black holes are not truly eternal. He discovered a gentle, subtle process by which black holes slowly leak particles and radiation over immense time spans, gradually shrinking as they do so through a mechanism now famously known as Hawking radiation. This mind-bending phenomenon occurs entirely because of the bizarre quantum mechanical effects that happen right at the edge of the event horizon. In the incredibly strange, microscopic world of quantum physics, empty space is never truly empty. Virtual particle pairs are constantly popping into existence from the vacuum, and then immediately annihilating each other. But near a black hole's event horizon, the intense gravity can gently pull one member of such a pair into the black hole, while allowing the other particle to escape freely into space. Over vast stretches of time, this quiet process actually drains mass and energy away from the black hole, causing it to slowly evaporate into the dark. The rate at which this Hawking radiation occurs is incredibly slow, especially for large black holes. A black hole possessing the exact mass of our Sun would take about 10 to the 67th power years to completely evaporate. That is a one followed by 67 zeros. But the supermassive black hole at the center of IC 1101 is billions of times more massive than our Sun, and the time required for it to evaporate is correspondingly terrifyingly longer. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to fully evaporate, or perhaps even longer. That number is known as a Google years, a 1 followed by exactly 100 zeros. To simply write out that staggering number in full would require more paper than currently exists on our entire Earth. It is a span of time so profoundly vast that everything we have discussed so far, from the explosive birth of the Big Bang to the quiet death of the very last red dwarf stars, is not even a measurable rounding error by comparison. It is as close to infinity as the human mind can possibly stretch. But even this incomprehensible span of time is not infinite. Eventually, trillions upon trillions upon trillions of years from now, in the deepest silence of the deep future, even the supermassive black hole at the very heart of IC 1101, will have radiated away its absolute last bit of mass and energy. It will disappear from the universe entirely in a final, brilliant burst of Hawking radiation, a momentary flash of light in a universe that has been completely dead for a googol years. When that final moment eventually passes, there will be absolutely nothing left of IC 1101 at all. There will be no shining stars, no dark matter halos, no frozen planets, and no silent black holes. There will be absolutely no physical remnants of any kind, just the sparse, wandering particles and the stretched, cooling radiation that once made up a magnificent galaxy, now spreading out infinitely through an ever-expanding, ever-darkening cosmos. The largest galaxy we have ever discovered, the massive cosmic empire that consumed dozens of its neighbors and held 100 trillion stars, will have followed the exact same ultimate path as every other structure in the universe, dissolving perfectly and completely into the endless, quiet night. This grand vision of the ultimate future might initially seem incredibly bleak to our human sensibilities. It is natural to feel a sense of existential dread when confronting the absolute erasure of everything that has ever existed. But I invite you to look at this ancient mystery from a different, more gentle perspective. I find something strangely beautiful, something deeply comforting about this ultimate dissolution. It teaches us the most profound lesson about the true value of the present moment. IC 1101 exists right now in this incredibly brief, beautiful moment of cosmic history, when stars still passionately shine and majestic galaxies still brightly glow. It has existed for billions of years and will gently continue to exist for billions more. But in the grand, infinite sweep of cosmic time, the beautiful era of stars and galaxies is just a passing phase. It is a brief, miraculous flowering of complexity, nestled safely between the chaotic heat of the early universe and the perfect, cold emptiness of the far future. We are incredibly lucky to exist exactly during this flowering. We are lucky enough to have evolved conscious intelligence, to have built powerful telescopes, and to have pointed them upward at the dark sky. We are extraordinarily lucky to have discovered IC 1101 and to understand, at least in part, what it is, how it violently came to be, and how it will eventually peacefully fade away. In all the vast, sprawling history of the universe, stretching from the primordial Big Bang all the way to the final, silent heat death, this moment right now is profoundly special. It is the exact moment when the universe has successfully developed the gentle ability to look at itself and experience wonder. And what we see when we look at IC 1101 is the grandest possible scale on which the universe has managed to assemble ordinary matter into highly organized, magnificent structures. We see billions of years of cosmic history written out in the light of stars. We see the dramatic results of countless galactic mergers, countless collisions, and countless acts of gravitational violence that have somehow, miraculously, produced something utterly magnificent. We see a terrifying monster, yes, but we also see a beautiful, quiet monument. It is a monument to the ancient forces that carefully shape our universe, and to the natural processes that have been quietly building complexity ever since the very first atoms formed in the dark. As we drift through this understanding, we find a profound peace in knowing that our minds can capture the entirety of a galaxy's lifespan, holding its violent birth and its quiet, fading death within the gentle bounds of our own imagination. We do not need to fear the end of things, because the very fact that we can comprehend the end makes us a vital, beautiful part of the cosmic story. This quiet acceptance transforms our initial existential fear into a deep, abiding comfort. We belong to the universe, and every single discovery we make is just another way of returning to our ancient home in the dark. Have you ever looked at the quiet, hazy band of the Milky Way stretching across the night sky and wondered if our gentle home is somehow immune to the violent forces that shaped the terrifying giants of the deep dark? When we gaze into the unfathomable distances at a monster like IC 1101, it is incredibly easy to feel detached, to view its chaotic history of galactic cannibalism as something that only happens out there, in the remote, harsh corners of the universe. We think of our own spiral galaxy as a peaceful sanctuary, a quiet island where our sun and its family of planets can orbit in perfect harmony. But the cosmos does not play favorites, and the fundamental laws of gravity apply just as strictly to our local neighborhood as they do to the heart of the Abel 2029 cluster. We, too, are actively participating in the ancient, relentless cosmic dance of gravitational interaction and galactic merger. Right now, as you breathe softly and listen to the quiet of the world, our very own galaxy is in the ongoing process of consuming several of its smaller neighbors. The Canis Major dwarf galaxy is currently being slowly, inevitably ripped apart and permanently absorbed into the sprawling body of the Milky Way. The Sagittarius dwarf galaxy is being severely stretched and distorted by our massive gravitational pull, leaving long, ghostly streams of ancient stars tracing across our sky. These streams are the silent, fading reminders of galaxies that once proudly existed as entirely separate entities, now becoming nothing more than food for our own cosmic home. If you are finding a moment of quiet peace and intellectual safety in this exploration of our magnificent universe, please allow me to briefly welcome you. I am Theodore, the researcher, your gentle companion on this infinite journey through the cosmos. I have noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find calm and a sense of connection to the greater mysteries, please consider taking a gentle moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together. Now, let us look forward into the deep future of our own cosmic backyard, where an event of unimaginable scale is quietly approaching. While we are currently consuming small dwarf galaxies, an even more dramatic event awaits us in the deep future. The Andromeda Galaxy, our nearest large neighbor, containing roughly 1 trillion stars, is currently heading directly toward us through the dark void. For many years, scientists believed that in about 4 to 5 billion years, the Milky Way and Andromeda would inevitably collide, eventually merging into a single, much larger galaxy nicknamed Milkmeda. However, recent scientific research has gently introduced some fascinating uncertainty into this long-held prediction. New, incredibly precise studies using detailed data from the Gaia spacecraft and the Hubble Space Telescope suggest that the catastrophic collision might not be as absolutely certain as we once thought. When astrophysicists account for the complex gravitational influence of other nearby galaxies, such as the Large Magellanic Cloud and the Triangulum Galaxy, the mathematical probability of a direct collision drops significantly. Some advanced computer simulations now suggest there is only about a 50% chance of a major merger actually happening within the next 10 billion years. But Whether this monumental collision happens in 4 billion years, 10 billion years, or perhaps not at all, the sheer potential of the process itself beautifully illustrates the exact same forces that originally created IC 1101. Galaxies interact, they merge, and they relentlessly consume each other in the dark. It is simply the fundamental way of the universe. Even our own quiet corner of the cosmos actively participates in this grand cosmic competition. If the grand merger between the Milky Way and Andromeda does eventually happen, the physical results would be absolutely spectacular on vast cosmic timescales. The initial collision itself would not be violent in the destructive way you might imagine. The distances between individual stars are so profoundly vast that the chances of any two stars actually hitting each other are essentially zero. The two galaxies would pass through each other like ghosts, a silent mingling of light in the dark. But the gravitational effects on the overall structures would be incredibly dramatic. The delicate, beautiful spiral arms of both galaxies would be completely destroyed by the immense tidal forces as the two giants swing past each other and fall back together. The massive clouds of interstellar gas within them would be severely compressed, instantly triggering enormous, brilliant bursts of new star formation. Deep within the chaotic center, the two supermassive black holes at the cores of each galaxy would eventually find each other in the swirling dark and merge together, releasing unimaginably powerful gravitational waves that would ripple silently across the entire universe. Over billions of years, the initial chaos would gently settle down into a new equilibrium. What was once the beautiful Milky Way and what was once the sprawling Andromeda would permanently blend together into a single, massive, elliptical galaxy, looking very much like IC 1101, though significantly smaller in scale. Future astronomers might dig through ancient records and marvel at the fact that their smooth, featureless home galaxy was once two beautiful spirals dancing gracefully through the void. By that incredibly distant time, of course, our beloved Earth will likely be long gone. Our reliable sun is expected to expand into a massive red giant in about 5 billion years. As it swells, it will grow to a size that would completely engulf the inner planets, very likely including our own fragile world. Whether humanity manages to survive until then, whether we successfully spread our consciousness to other distant star systems, or whether intelligence of any kind persists in the evolving universe, these are profound questions that we simply cannot answer today. But the ancient story of IC 1101 and the impending story of our own Milky Way gently reminds us that the universe operates on time scales that completely dwarf individual lives, entire civilizations, and even the lifespans of individual planets. We are fleeting thoughts in the mind of the cosmos. Yet, rather than letting this realization crush us with a sense of insignificance, I invite you to consider what this understanding truly means for our unique place in the universe. When you step outside and look up at the vast night sky, it is incredibly easy to feel small. You might feel entirely insignificant in the face of such overwhelming vastness. But I truly believe that the very existence of a monster like IC 1101 actually tells us something profoundly hopeful and beautiful about our specific situation. First, consider the absolute miracle that we can know about IC 1101 at all. Here is a massive galaxy sitting more than 1 billion light-years away from us, containing 100 trillion stars, and yet we have somehow figured out exactly how big it is, exactly how it formed, and exactly what kind of monster lies quietly at its center. That is a staggering achievement. Human beings, living brief lives on a small, rocky planet orbiting an ordinary star, have somehow developed the exquisite ability to understand objects so unimaginably far away that their light left before a complex life even existed on our world. This profound ability to understand is not nothing, it is everything. In a universe largely composed of mindless matter, dark energy, and cold particles bouncing around, somehow, here on Earth, true consciousness has emerged. We are minds that can wonder, question, investigate, and actively learn about the dark. Whatever else we might be, we are the specific part of the universe that has finally woken up and started asking deep, meaningful questions about itself. We are the cosmos discovering its own terrifying scale and its incredible beauty. Second, consider the profound physical connection we share with these distant giants. IC 1101, for all its terrifying enormity and its billion-year distance, is made of the exact same physical stuff that we are. The trillions of stars in IC 1101 are immense nuclear fusion reactors, operating on the exact same principles as our own sun. They constantly burn hydrogen into helium and forge heavier elements in their cores, just like stars do everywhere in the cosmos. The specific atoms glowing in those unimaginably distant stars are the exact same kinds of atoms that make up our fragile human bodies, the carbon in our cells, the oxygen we breathe, the nitrogen in our DNA, and the iron in our blood. All of these heavy elements were originally forged in the blazing hearts of ancient stars somewhere in the universe, just as the atoms in our earthly bodies were forged in primordial stars that exploded long before our own sun was born. There is a deep, unbreakable continuity here, a physical connection between us and everything else in the entire cosmos. We are not separate from the universe, looking in from the outside. We are an integral, physical part of it. The exact same physical processes that built the colossal form of IC 1101 also built the delicate structures of our eyes and our brains. The exact same types of ancient atoms that currently shine in distant dying galaxies also shine brightly in our eyes when we look up at the dark sky. We are not mere passive observers of a grand theatrical universe. We are the universe observing itself from within, trying to make sense of its own sprawling history. This beautiful realization completely transforms our relationship with the cosmos. We no longer need to fear the infinite dark or feel crushed by the massive scale of billions of light years. Instead, we can look at the largest galaxy ever discovered and see a distant reflection of our own physical origins. We can find a profound, quiet peace in the knowledge that we belong here. We are an expression of the cosmos, fleeting but fully awake. Let us carry this profound connection in our hearts as we prepare to take one final look at the magnificent legacy of the universe's greatest giant. Have you ever deeply considered that the universe, in all its terrifying vastness and chaotic violence, did not actually have to exist in a way that allows us to be here observing it? When we study the fundamental constants of physics, we discover a delicate, almost miraculous balance that gently defies our understanding of random chance. If the physical laws that govern reality were even slightly different, if the force of gravity were just a little bit stronger, or the nuclear forces a little bit weaker, the brilliant stars and sprawling galaxies might never have formed in the dark. The entire universe might have violently collapsed back upon itself mere moments after the Big Bang. Or it might have expanded so incredibly fast that primordial matter never had the gentle opportunity to clump together into the structures we see today. Instead, we find ourselves living in a universe where the precise physical laws perfectly allow for the slow, majestic formation of stars, planets, galaxies, biological life, and ultimately, conscious mind. IC 1101, with its 100 trillion stars and its 50 billion solar mass black hole, is a monumental testament to exactly what is possible in such a finely tuned universe. It is absolute proof that ordinary matter and invisible energy, blindly following simple physical rules over billions of years, can organically organize itself into cosmic structures of staggering complexity and terrifying beauty. If the universe can naturally produce a giant like IC 1101, we must humbly ask ourselves, what other incomprehensible wonders exist out there in the dark that we have not yet discovered? If you are finding a quiet sanctuary in these deep explorations of the ancient cosmos, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this journey through the endless wonders of space. I have gently noticed that exactly 71% of the people who watch our videos and share these contemplative moments have not yet subscribed to the channel. If these cosmic stories help you find a deep sense of peace, intellectual safety, and a profound connection to the greater mysteries of reality, please consider taking a moment to subscribe. It helps us immensely and ensures that we can continue to wander through the beautiful, ancient dark together, unraveling the quiet truths hidden in the vastness of space. There is a famous, deeply moving photograph called the Hubble Deep Field, which was taken in the year 1995. Astronomers pointed the Hubble Space Telescope at a tiny, seemingly empty patch of the night sky, an area roughly the size of a single grain of sand, held at arm's length against the dark. It painstakingly gathered ancient light for over 100 hours. What the resulting image ultimately revealed was absolutely astounding, permanently altering our perception of the cosmos. That tiny patch of sky actually contained about 3,000 individual galaxies, each one a magnificent island universe containing billions of its own shining stars. The philosophical conclusion drawn from these images is inescapable and profoundly humbling. Everywhere we look, no matter how incredibly small the area of sky might be, we find galaxies. The universe is absolutely filled with them, perhaps 2 trillion in total, spread across billions of light years in every conceivable direction. IC 1101 is just one of those 2 trillion galaxies. It is a highly exceptional one, yes, but it is still just one single galaxy among countless billions floating in the dark. The simple fact that we have deliberately singled it out, carefully studied it, and come to deeply understand its violent history is a beautiful testament to human curiosity and our relentless ingenuity. I want to reflect on what it truly means to know something so profound about IC 1101, something that no human being knew just a few short centuries ago. William Herschel, when he first spotted this distant object through his telescope in the year 1790, could have had absolutely no conception of what he was actually looking at. He saw nothing more than a faint, fuzzy blob of light. We, on the other hand, see a sprawling empire of 100 trillion stars and billions of years of complex cosmic history. This staggering progress required countless dedicated individuals contributing their small pieces to the grand puzzle. Astronomers building bigger telescopes, physicists working out theories of light, and mathematicians developing tools to analyze falling starlight. When you sit quietly and think about IC 1101, you are actively participating in a grand tradition of human inquiry that stretches back across the centuries. You are standing securely on the shoulders of giants, seeing farther into the dark because of the accumulated efforts of all who came before us. The deep understanding of IC 1101 is not the private property of any single individual. It beautifully belongs to humanity as a whole, serving as a shared heritage of knowledge that completely transcends any single person or nation. There is something deeply, profoundly democratic about this cosmic perspective. Astronomical knowledge is freely available to anyone who simply wants it. You do not need to be wealthy or powerful to learn about the secrets of the universe. In a modern world that often seems fractured and divided, the shared pursuit of cosmic knowledge is something that silently unites us all. The stars shine equally for everyone, and the scientific truth about IC 1101 is the exact same truth everywhere on Earth. Throughout this long contemplative exploration of the universe's greatest giant, I have tried to gently convey not just the cold scientific facts, but the deep, resonant feelings they evoke. Wonder is very often dismissed in our modern society as something childish, something we are supposed to outgrow as we become serious adults. But I firmly believe that a sense of wonder is absolutely essential to living a good, meaningful life. It gently opens our minds to experiences far beyond the mundane every day. It quietly reminds us that there is vastly more to existence than our immediate, temporary problems. IC 1101 is a magnificent occasion for true wonder. 100 trillion stars, 4 to 6 million light-years across, and 1 billion years of light travel time. These are numbers so impossibly large, they gently strain our human comprehension. The true wonder of science is not just the magnificent objects we study, but the very fact that conscious matter has evolved the ability to look out at the cosmos and make sense of what it sees. I want to leave you with one final, deeply comforting thought as we conclude our journey. The very atoms that currently make up your physical body were forged in the blazing hearts of ancient stars. The carbon that constructs your muscles, the oxygen you gently breathe into your lungs, the iron that carries life through your blood, all of these heavy elements were miraculously created in the nuclear furnaces at the cores of stars that lived, burned, and violently died long before our own sun was ever born. When those ancient primordial stars exploded as brilliant supernovas, they generously scattered their elemental riches across the empty space. They became the earth, and then, after billions of years of gentle, relentless evolution, they became you. You are literally made of star stuff. The exact same physical processes that currently light up IC 1101 stars has also created the very matter from which your eyes and your brain are assembled. In a very real sense, when you quietly contemplate IC 1101, you are star stuff contemplating more star stuff. We are the universe actively looking at itself, trying to understand what it is and how it miraculously came to be. As we wrap up this exploration, imagine yourself floating in the silent space somewhere near the fading edge of IC 1101. Around you, in absolutely every direction, trillions of ancient stars stretch out toward infinity. Each one is a burning sun, and each one has been shining for billions of years. You are lost in a vast sea of light, adrift in a structure so unimaginably vast that crossing it would take millions of times longer than human civilization has even existed. And yet, from a small rocky planet more than 1 billion light-years away, beings who live for less than a cosmic instant have figured out that this magnificent place exists. When you next look up at the night sky, remember IC 1101. It is there, in the constellation Virgo, shining with the ancient light of 100 trillion stars. It will remain there for billions of years, slowly fading into the cosmic night, but not yet gone. We are an integral part of a universe that contains such staggering wonders. The biggest galaxy we have ever discovered is truly bigger than your imagination, but the profound fact that you can imagine it at all is perhaps the most amazing thing of all. Thank you for joining me on this quiet journey through the dark. If this video helped you see the universe in a new way, please consider leaving a comment letting us know what you think about our place in a cosmos that contains such wonders. And if you want to keep exploring the mysteries of the universe with us, do not forget to like this video and subscribe to the channel. Until next time, keep looking up and keep wondering in the dark.